from Idaho. I strive to provide interesting videos about motorcycles, fabrication, welding, electronics, machining, and general creativity. I hope you enjoy. Okay, here's where the video should have started. I've got my square sitting on the base and just touching the saw blade. Now I'm going to let the saw blade down and you'll see a gap appear between the saw blade and the square. This is how much off my saw was cutting. Hello from Idaho. I'm actually in the middle of the roof rack project for my XJ, and my bandsaw is annoying me. I've owned it for 20 years. It was used before I got it. That I rebuilt it, put in new bearings and whatnot. But it is always cut crooked, top to bottom. And you don't really notice it when you're cutting off, small things. But if you need to cut off, like I was cutting pieces out of this 3-inch square tubing for my brackets. For the roof rack, and by the time I get to the bottom, I'm off a 32nd of an inch. And I discovered that pretty quickly after I bought it. I didn't take measurement tools along with me when I did buy it. But at any rate, it's annoyed me enough. So I've stopped my roof rack project, and I've got this emerging problem. Well, what controls that pivot is this axle. The bandsaw has a piece that hooks here and a piece that hooks there, and so whether it goes up and down straight or not is this axle. So this axle needed to come up on this outboard side probably at least a 1/16 of an inch. Well, it was built in. I've already got it cut apart, so unfortunately I started the video in the middle, but these pieces were cast into the base, and they used to have tops on them, but I cut them off so that I could get some accurate measurements of the axle. At any rate, this side needs to be raised up, and I thought about putting this in my milling machine and counter boring it and building a brass bushing. And the problem with that is I would have to guess how much, because I don't really know how much it's going to take here. And so I finally hooked upon an idea that allows me to make it adjustable. Well, that comes with major commitment and major surgery. So I have cut the ears off, made it perfectly flat here, and I bought a plate that will sit here on this casting and bolt down to the casting, and then I'm going to make something that I'm going to make bushing here that accepts this shaft. This is 1 1/4 inch DOM with 1/4 inch wall. So right now it's sitting at 3/4 of an inch. And so I will bore that out, weld it onto this plate, and I got alignment marks and whatnot marked on the casting. So, and then once I get it cut off, that axle will go in there as normal and the saw will still pivot as normal. But I will be able to shim it up in increments as small or as big as I need. And so I don't have to know exactly how much shim it's going to take. I can just I'll start with pizza 16th inch shim, put it under there. I've got little pilot holes drilled in the casting that I will bore out to 3/8, and I'll put some 3/8 holes in this, and that way I'll be able to shim it as much or as little as it needs. Anyway, that's why I'm in the middle of this project right now. I just got done with my death wheel, cutting off those axle bosses and smoothing this up, and I'm about to go to the lathe and make a pivot for that axle. Well, it is certainly a good day to be working in the shop. We get a nice, steady, fairly hard rain. About 15% humidity, about 58 degrees. This is part of Idaho's September-October weather. Okay, I've cut off 2.5 inches of my 1 1/4 inch DOM tubing. I'm going to face the end and then bore up to roughly 7/8. My shaft is nominally 7/8 at the about 0.873 or 0.874. After I polished it, it's been in there for 30 odd years. So the objective is to bore out the center to have a good running fit, not a press fit, but a hard sliding fit, so there's no slop in it. All right, so we've got a uninterrupted cut now. So we'll do a little chamfer here. Blondie Hex says that distinguishes us from the animal. Okay, time for the boring bar. My boring bar will reach about 2.5 inches, which is why I cut the bushings to 2.5 inches. That's plenty of bearing surface for the axle. This is a low speed, low stress joint that I'm working on. Okay, we're coming out on what may be the second to the last pass. I've started cutting both ways and feeding on my slowest speed. So I'm getting a good finish, and I'm minimizing the spring back in that long, slender boring bar. So let's see what the guessometer says. The actual go, no-go will be the shaft, but this lets us know if we're getting close. So we are at 867. So we are about 5 thousandths off. Let's take another 5 thousandths cut. Probably more like 7 thousandths off. We'll continue to sneak up on it. Okay, we're cutting out on what might be the last pass. One fly in the ointment here is that no matter how well I make it fit, I still got to weld these to another piece of metal, and that will shrink them for sure. I'll use a TIG weld instead of a MIG weld, which will help mitigate some of that, but I fully expect that I will have to clean up the inside of these bores after the weld. I don't have a machine to do that on, so I'll have to do it manually, but we'll make it fit. Like I said, it's not a high-speed connection, but I would like it to be zero slop after I'm going to all this trouble to adjust an error out of the machine. Okay, we're cutting the last little bit. Okay, the survey says .874, that's what we were shooting for. Let's see how this goes. Okay, that's a little tight. That end will go in. I had no misgivings that this shaft was perfect on both ends. So this is a good fit on one end. And I've got another bushing that I did that is a good fit on the other end. And so I think I got it. Yay, now we get to clean up our mess. Okay, we're all set up to tack weld. This contraption here is to make sure that the bottom of the new plate is at the same level as the bottom of the axle, which is what measurements that I took off the original arrangement. And so this, when I bolt this down, it will put the axle in the same position height-wise that it was, which is important because the saw needs to come down at the finish of the cut far enough and not be at an angle. So I need the bearing sticking out a 1/16 of an inch on this side and 5/8 of an inch on that side to match the original setup. hard to do a fusion tack in the corner, but I got a little one in there. That was a hot place to put my finger. Okay. Got 4 little tacks. Enough that I should be able to turn it over and tack the other side. Okay, now we can just lay down some beads. Okay, time to make some holes in or drill these pilot holes out to receive my plate. Still got it set on ratcheting. Okay, I've got the plate and the axle on the bandsaw ahead. I've got, it moves with, I don't know, 3 pounds of resistance or something like that, so I got no slop. and I got no slop side to side. So far, it's beginning to look like a good solution. Problem is, this piece is heavy enough that I can't really lift it very easily, so I'm going to have to play some games with the hydraulic welding table and the top of the saw. Okay, we're going to try to get the saw head back on the base. Got it turned over, oriented as close to what I need as I can. Okay, here's where the video should have started. I've got my square sitting on the base and just touching the saw blade. Now I'm going to let the saw blade down, and you'll see a gap appear between the saw blade and the square. This is how much off my saw was cutting. I've got it back together right now with the adjustable bearings, but I don't have any shims in, so I should be able to shim this out of it, which is the point of the whole exercise. Okay, I have a 1/8 inch shim in, all by itself. So let's see how straight it cuts. Still don't quite have the shut-off switch set correctly, but we're getting closer. I guess some things in life are iterative. Okay, let's see how we did. Looks like we are a lot closer to straight. Just a guess. Holy crap. My square touches the top and the bottom at exactly the same time. So a 1/8 inch shim all by itself is the solution. Okay, we're handheld now, so it might be a little jiggery, but so remember that these little bosses like this, actually they were full circle, used to be part of the frame right here. And so we cut all those off. We made a plate to bolt to the frame, through the frame, and made a couple of bearings, for lack of a better word, for the axle to run through. Welded that all together, and then made the axle fit the bearings again because welding shrunk it a little bit. But I got a really tight fit here. I got some oil holes that I will, now that I'm done messing with it, I'll put oil in it. And right under here is where the shim goes. Right between the plate and the frame is this 1/8 inch gap, and there's a 1/8 inch aluminum spacer in there that looks just like this one, but this is 1/4 inch. And so with that, I will say I'm a happy camper again. I can now cut things without worrying about them being crooked and have to clean them up on the bandsaw or the milling machine. And this works as it should have from the factory. So goodbye from Idaho, and hope you have a good day. Maybe this will help somebody else. As usual, if you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments, and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.